All right, guys, so I wanted to show you how we find the area of a weird looking shape, because as you start to construct your floor plans, you're going to realize that your house is not designed as a perfect rectangle. There's going to be a lot of weird shapes. But usually we can break down a shape into rectangles. And that's what we have here. So think of this as the outline of a floor plan. Maybe it's a school or a business, and we need to ultimately find the area as if we're calculating how much flooring we're going to need. So my biggest recommendation is to break this apart into smaller rectangles. There is not one correct way to break this down. So I'm going to show you one way that I chose to break it down, but you do want to be creating rectangles as you work on this. And the simpler the rectangle, the better. So I noticed that I kind of have these rectangles shooting off in different directions across the side. So my approach is that I'm going to try to kind of break off these rectangles on the edge. So this worked pretty smoothly. I do need to add one more line up here to get another little skinny rectangle up top. And then I have sort of a nice arrangement of rectangles that should be fairly straightforward. So I'm going to start up at the top because there is a tricky part up at the top. So we know that our area formula for rectangles is length times width or base times height. So those are the dimensions that we need. So when I look at this very top rectangle here in purple, I have a length and a width of 5 and 7. So when I multiply those together, I get 35 for that rectangle. But when I go down and try to find this sliver here in purple, I need to make sure I'm looking very closely at what the dimensions are. So I can tell that one of my dimensions is 1, but I need to figure out what this whole length is in purple. So we have to kind of look around and see what we know. So I know that this is 5 and I know that this is 10. I also know this is 4. So let's kind of work with those. If this distance here is 4, then that means this distance is also 4. And if this whole piece is 10 and I subtract 4, I'm left with 6 on this side. Now, again, on the top rectangle, I know this distance is 5 up at the very top, and I know this is 2. So this little piece right here would be left to be 3. So now I can see that if I add the 3 plus the 6, I get 9 for that purple distance in that little skinny rectangle. Length times width would be 9 times 1, so that little sliver is 9. Okay, so that was a little bit of a tricky part. So now I'm just going to work my way around the other rectangles. So here I have 5 times 4, so that area is 20. Down here I have 8 times 6, so that area is 48. Then I have 12 times 6, that area is 72. Then I have 2 times 9, so that is 18. And then I have 5 times 3 here, so that's 15. So that was pretty easy to get those rectangles on the outer edge. But now I need to focus on that big center rectangle. So I'm going to have to get this distance here and this one to be able to do length times width. So as I work my way down, I have this distance of 4. And then if this is 3, this side of the rectangle is 3. Then I have this as a distance of 4. And then if this distance is 2, that is also 2. So when I add up all these, 4 plus 3 plus 4 plus 2, I get, 13. Okay, now I need to find the other dimension. So it looks like I have it looks like I have the dimensions that I need up at the top. So if I look up at the top here, I already figured out that this is 9 and I know this is 5. So 9 plus 5 is 14. So length times width, 13 times 14 is 182. So now we have all of the areas, and we just have to add them together. So you're adding 35 plus 9 plus 20 plus 48 plus 182 plus 72 plus 18 plus 15. I think I got them all. So your total area should be 399, and then that would be squared units.